Hi, my name is Johnny Wise. I'm a postdoc at the University of Louisville, and I recently received a high score on an R21 grant to investigate how hexavalent chromium is neurotoxic and how it might contribute to brain aging. It's important to understand we're in the midst of a global aging epidemic, where by the year 2050, at least 25% of the global population will be over the age of 65. At the same time, we're facing a global crisis of environmental pollution, and we have a poor understanding of how this environmental pollution will affect our elderly different from younger populations. First, I want to talk about how toxicology and aging interact from two sides of the same coin. On the heads side, we consider how chemicals affect us differently at different ages, young versus middle age versus elderly. And then on the tail side, we consider how chemicals contribute to the aging process throughout our lives. So I need you to understand one key vocabulary word, a gerontogen. Coined in 1987 by George Martin, a gerontogen is a chemical that induces or accelerates the aging process within our cells and our tissues. I'm proposing heavy metals as a class of gerontogens, and I'm using hexavalent chromium as my candidate metal. While rare in nature, hexavalent chromium has become a significant environmental pollutant due to its heavy use in industry, and as such we often encounter it in our air and our drinking water, and it accumulates in our bodies throughout our lives. We have a relatively poor understanding of how hexavalent chromium is neurotoxic, but we recognize that it accumulates in our brains, and the highest levels observed are in the pituitary and the temporal lobe. Now, we don't understand how these levels affect our brain health or our behavior, and we also don't recognize which regions of the brain are most vulnerable or which cell types are the most vulnerable. So that's the first thing that my grant seeks to address. I'm going to use a model where I expose rats to hexavalent chromium in their drinking water for 3 months. I'll use 3 different age groups, a young, a middle-aged, and an elderly. And first, identify which cell types are vulnerable to hexavalent chromium, which regions are vulnerable, and if this is different at different ages. Now, the second aspect of my grant is to look at a new mechanism for aging. Hexavalent chromium is well known for inducing DNA double strand breaks in cells, and here I'm showing you how, from a pilot study, hexavalent chromium induces gamma H2X foci and brighter gamma H2X staining in the nuclei of treated rats versus control rats. DNA damage is known to accumulate in our cells throughout our lives, and this accumulation of DNA damage can contribute to chromosome instability. The persistence of chromosome instability contributes to cellular senescence, which contributes to systemic inflammation. Now, given our limited understanding of chromium neurotoxicology, gerontogens, and age effects of toxicology, the results I produce will be major breakthroughs towards providing a safer environment for our elderly and all of our futures. Thank you.